So usually testing a front-end framework isn't easy, but React makes this quite simple. React is built on the idea that components produce HTML based on props and state. The simple design makes testing React components quite straightforward compared to many alternative UI designs. Here's what we'll cover in this module. If you're new to automated testing, just deciding what to use can be a major hurdle itself. So we'll begin by reviewing the long list of options to consider in this space, including testing frameworks, assertion libraries, and helper libraries. Once we've clarified our testing stack, we'll spend the rest of the time back in the editor writing tests. We'll test the same components using React Test Utils and Enzyme in order to contrast the benefit of each approach. As you'll see, we can simulate a render without opening a real browser. And we can pass properties to our components, simulate interactions, and assert on the results of these interactions. Now this is a big topic with a lot of ground to cover, so I'm going to show you one way to get this done with my preferred tooling. But know this, there are many other options out there if you don't like what you see here. The first thing we need to decide is what testing framework we're going to use. There's a wide variety of JavaScript testing libraries available, so we'll just go through a few right here. Mocha is the most popular library because it's configurable and it has a very large ecosystem of support. Jasmine is similar to Mocha, though I think Mocha is still more configurable. Jest is from Facebook. Jest is very similar to Jasmine because it's basically a wrapper around Jasmine that adds some unique features like mocking by default. And you'd think that Jest is more popular given that it's from Facebook, but as you'll see in a moment, it's not. Tape is arguably the leanest and simplest library of the bunch. Its simplicity and minimal configuration are its key strengths. And Ava is the newest testing library from all of these. And I like what I see so far. Ava uses Babel behind the scenes, but it's pre-configured for you and installed as dependency when you install Ava. This makes getting up to speed quicker and also makes the command line for running tests simpler. I really enjoy using Ava, but I decided to go with Mocha for this course and for this last reason. Mocha is mature, proven, and has a large ecosystem around it. Now that said, I really recommend trying out Ava as well. Now, Mocha doesn't come with assertion libraries, so we'll have to pick out our own. The most popular option is Jai, but I'm going to be using Expect because it's simple and has a small API, which I consider a good thing. Expect is a nice simple alternative to Jai created by Michael Jackson, who was the core contributor to React Router. Expect has become quite popular in the React community, and it's used in Redux examples as well. So in this course, we'll use Expect. As you can see in the stats, Expect has become extremely popular despite its lack of flashy website and the fact that it's rather hard to Google for. So why did I choose Expect? As you can see, Jai uses a chain-based API, so you end up typing out more dots in your assertion. Instead of method chaining, the Expect library offers a short list of functions that seek out to mimic the way that we speak. I find this easier to read and type, so I personally prefer Expect. Now that we have chosen a testing framework and an assertion library, we need to choose a helper library, so let's do that next. The next big question that we need to answer before starting and writing tests is, should we use a helper library? And if so, which one? There's a variety of libraries that can help make testing with React and Redux easier, but in this module, we're going to explore the two most popular options, which is React Test Utils and Enzyme. Let's discuss React Test Utils first. React Test Utils is a library that specifically is for testing React components. It's both built and supported by Facebook. The library is very powerful, but as you're about to see, it does have some rather verbose API. React Test Utils offers some very helpful testing utilities. Things like Shallow Render lets us render the component that we're testing without having to render any of its children. That's why it's called Shallow Render. It renders only one level deep. Shallow rendering is useful to constrain yourself to testing a component as a unit and to ensure that your tests aren't indirectly asserting on behavior of child components. When testing with shallow render, no DOM is required because shallow render returns an object that mirrors what we'd expect to see in the real-world DOM. We should prefer this approach when possible because it's fast and simple. But sometimes you want to simulate interactions between components or interactions with the DOM, such as clicks and change events. That's when shallow render is no longer sufficient. Instead, you can use something like render into document because it actually renders the component onto the DOM. So this function requires a DOM to be present. So that doesn't mean that you have to fire up a browser when you use it. This is where libraries like JSDOM come in handy because they offer a simulated DOM in Node that you can interact with just as though you were actually in a browser. React Test Utils also offers a variety of functions for querying and interacting with a DOM. Find rendered DOM component with tag is useful for finding specific DOM elements by tag. And scry rendered DOM components with tab finds components by tag name. As you can see, these names are very verbose. Honestly, the React Test Utils API has some really useful functions. Shallow render and render into document are really helpful, but the functions for querying the DOM are really wordy, and they feel very clunky as well. And you'll see in a moment there are some alternatives to using this API that are much less painful. Before we move on though, one more feature to discuss, which is simulate. Once you have a reference to a specific element, you can simulate interactions on the element using the simulate function. You can simulate any event that React understands: clicks, key presses, form submissions, scrolling, and so on. Simulate is very useful for simulating interactions with your component and then asserting on the outcome of that interaction. Now, as I mentioned, I find this API rather difficult. See, React is terse and elegant, and this API is neither of those. And of course, I'm just showing you a small portion of this API. You can check it out in the full docs if you'd like. When you consider these APIs side by side, it's pretty clear why Enzyme is becoming so popular. Enzyme's find function is ultra versatile since it accepts a useful subset of CSS selectors. So, if you already know jQuery, it's really easy to find what you're looking for with Enzyme. Of course, Enzyme's API offers a lot more than just find. Enzyme is a project by Airbnb, and they have excellent documentation. If you view the documentation on usage, you can see that there is a large API that very closely mirrors interacting with jQuery, where you can use things like is, not, children, parents, close list, shallow, text, and so on. And you can get references to state and props by saying .props and .state. So it's a very nice terse API that gives you what you need without doing a whole lot of typing. And it definitely rolls off the tongue a lot more naturally than the API that we just saw with React Test Utils. So I'm jumping into Enzyme without really explaining exactly what it does here. Now keep in mind that Enzyme is just an abstraction. It's kind of like theater production. So let's look behind the scenes and understand what the Enzyme is really doing and how it works. Enzyme is ultimately calling React Test Utils behind the scenes. It's an abstraction over that provides a nicer API. Now it also uses some other open source tools that are very useful. It uses JSDOM to provide an in-memory DOM for test so that we can run our test in Node without using an actual browser. It also uses Cheerio to provide jQuery-like CSS selectors. This is a feature that I really like. If you already know jQuery, then picking up Enzyme is really easy. With Enzyme, these three libraries come together to create a very powerful and terse testing API and environment. And we don't have to configure these tools to make them work together. Enzyme pulls them together in a nice logical way for us. And again, with Enzyme, you don't have to open the browser. Our tests run in memory via Node. As I just alluded to, we're planning on running tests in memory via Node, but I want to step back for a moment and discuss the options for where we can run our test. There are three popular ways to run JavaScript-based tests. The most obvious option is running our test in the browser. Karma is a popular test runner for running tests in a real-deal browser. However, opening an actual browser requires some configuration and is slower than alternatives, so I prefer avoiding this approach. Instead, we can utilize a headless browser like Phantom.js to run our test. I've used this approach successfully in the past as well, but for this course, we're going to go with option 3, which is just using an in-memory DOM. Enzyme uses JSDOM behind the scenes to provide an in-memory DOM. JSDOM simulates the actual browser by creating a DOM in memory that we can interact with. The advantage of this approach is that it's fast, quick to set up, and allows us to run our test via Node. While we're talking about where to test, let's also talk about how to name our test files. So in my research, I found that .spec was the most popular and .test.js was the second most popular. And that's the extension that actually we're going to be using in this course. If you don't like the naming convention that I'm using, just remember that it's just an easy one-line change in the package.json file. Another big question is, where do we place our test? Mocha defaults to looking for test in the /test folder in the root of our project, but I prefer to place my test alongside the file in test. Why? Well, there's a number of reasons. First, I find that it makes paths easier to work with. Since the test and the file under the test are in the same path, imports are nice and clean. It's always /file name under test, whatever it is. And I certainly prefer this over managing long relative file paths. Second, it provides clear visibility to our test. They're not buried in a separate folder, they're just right here in our source. So it's quite easy to notice a file that lacks the corresponding test file. Third, placing them together makes it easy to open them at the same time, and it's also more convenient when we refactor and move files as well. When they're placed separately, moving a file under test requires updating the path in the corresponding test file. When they're placed together, you can easily move them together with no changes required to the code itself. Now it's time to review our plan of attack. We'll test both React components and Redux. We'll use Mocha with expect as our assertion library, and then we'll test using an in-memory DOM via JSDOM. And we'll also use Enzyme because it pulls together all of this in a nice, easy-to-use package. Let's get started. Let's begin with the easy stuff. We'll write some tests for React presentational components first. As we discussed in the previous module, the vast majority of components in our app should be dumb presentational components. They should simply take some props and return some markup. This makes testing clean and simple. We can just assume that given certain props, we receive the expected output. Now when testing React components, we have to choose between shallow rendering and rendering to an actual DOM. Shallow render is faster than rendering to an actual DOM. Why? Because shallow rendering tests a single component in isolation. Child components aren't rendered. However, there is some limitation with shallow rendering. At the time of recording, shallow rendering doesn't support refs and testing interactions. These limitations may be solved in the future since Facebook is actively working on improving shallow rendering, and it also considers shallow rendering the recommended approach in the future. So we'll use shallow rendering to test our presentational components. But in the upcoming video, we'll need to test interactions between parents and child components, so we'll use the slower render into document style at this time. And to clarify, since we are using Enzyme, Enzyme labels render into document as mount. But understand that behind the scenes, Enzyme will be calling React test utils and using its render into document function because again, Enzyme is just an abstraction over React test utils. Let's use shallow rendering to test the same React components in two different technologies. First, we'll use React test utils, and then we'll do the same test in Enzyme for comparison. Before we get started with testing, I'd like to change a setting on Mocha's test reporter. Right now, I have this set to progress, but I want to change this to spec. I would normally like to keep this set to progress, but when I'm doing development, because it really helps minimize the noise that's written inside the console, I'd like to use spec. During our initial creation of tests, I think that you will find spec reporter more helpful because we'll be able to see details about the specific test that we've written. Now with all of that set up, we're ready to write our first test. First, let's add a test for the course form component. So I'll go over here to my course folder, and here's our course form, and I'll just add a new file. and I'll add courseForm.test.js. We'll begin by importing the libraries that we need. We're going to need expect, which is an assertion library, and we'll also need React. We're also going to need React Test Utils, which I'd already mentioned, which is available to us under the React Add-ons Test Utils. And finally, our system under test in this case will be courseForm. Now, let's add our describe block. If you're not familiar with Mocha, the describe block is used to group and label your test. So you can nest multiple tests inside. For the first test, we're going to test the structure of our component that we would expect. Normally, I would just give a name under the file right here, but I'm going to call this group of tests courseForm via React Test Utils because we're going to create the same test with Enzyme in a moment so you can see the contrast between the two approaches. For the first test, let's assert that a form and an h1 tag are rendered within our form. So I use the it function, which allows me to describe what I'm trying to test, which in this case is it renders a form and an h1. So I'm naming my test. Now to get started with React Test Utils, it's helpful to create a setup function that will return to us the output of rendering the component under test. So let's create a function called setup right up above. The first step here is to create an instance of the React Test Utils renderer. Now we can render the courseForm component. Finally, to get the output of this render, we need to call the getRenderedOutput. Now we're calling courseForm without any props. We need to pass some props in right here. So I could just add them in line here, but instead what I'm going to do is I'm going to declare them up here above for readability, and I'll just type out the object. And now I can just update the courseForm and put these props to use. And I'll use the spread operator to make that happen. Now remember, the spread operator works on objects too. So the syntax is equivalent of me typing out all the props one by one. Quite handy. And finally, let's return a few items from this function that might be useful in our test. So this way, we'll be able to get an object back that contains the props that we set up, the output, and the render in case we need it. And that's it. Now that we have our setup function, it'll be far less painful to work with React Test Utils. So let's shift our focus back to writing our first test. To begin, let's call the setup function that we just created and get a reference to the output property that is being returned. So this will be the output for us rendering the courseForm. And now that we have our hands on the output of rendering our courseForm, we can make assertions on it. First, let's write an assertion that the top level tag that we're receiving is form, because if we go and look at courseForm, we can see that the top level tag is form. So I'll open up the command line and I'll run npm test:watch. So this will run our test and then watch them as well. This way, anytime that we hit save, it should rerun our test. So we can see that we have two tests running, our first test, which we wrote in our environment setup module at the beginning of this course, and our courseForm via React Test Utils. And we can see both of them are passing. So our first test is passing. So now what we need to do is we need to get our hands on the courseForm and the form tag at the top level that we're receiving because the type is form. And now we can get a reference to child elements using output.props.children. So here I'm going to destructure the array that's returned from children and say that the first element is an h1. We're expecting the first element to be an h1 because if I go over to the courseForm and I look at the children underneath form, the first child is h1. Of course, the second child would be text input, the third child would be select input, and so on. But I'm just interested here in h1 for this test. So this is just saying that take the first element and give it a variable name of h1. And let's make sure that we have what we expect here, so we'll write out another expect statement that expects the type of h1 to be h1. Let's save here, and we can see again that our tests are passing. So great, we've completed our first React Test Utils. Let's add a couple more tests. Now that was obviously a pretty trivial test, so let's add something a little bit more interesting. Back over to my courseForm, if we scroll down to the bottom, remember this save button, and we wanted to change the value of this button depending on whether saving was true or not. When it was saving, we wanted to say saving, otherwise we want it just to say save. So let's write a test that asserts that this is working as expected. So I'll just type out the next test and we can talk about it. So what we have here is a test that is saying save button is labeled save when not saving, because we expect it to say save when we're not saving. So what we do is we call setup again. We get our hands on input, and then this time we're going to get the fifth child element so that the fifth child is a submit button. And the reason that this is the fifth is because of index here. So let's go see how this is the fifth element. We can come through here and say 0, 1, 2, 3, 4, 5. So it's an index of 5. And then what we do is write an expect statement based on the value of the submit button. We expect the value to be safe because right now what we did is we call setup with a parameter of false. Now if we look at our setup function, right now we can see that saving is hard-coded to false. So what we can actually do is take a parameter up here on setup, and we can call this parameter saving. So effectively, now we're adding a little bit of power to our setup function so that we can change the props that we're passing down to our course form. So now we've updated the setup function so we can pass a parameter to it. And I've already hit save, and you can see that our tests are passing. And the save function is now labeled as save when not saving. So now let's go ahead and do the opposite of this. We want it to say saving ... when it is saving. So you can see that we're calling the setup function, but this time we're passing true instead of false. So that will end up setting saving to true. Otherwise the code is the same. We're just asserting now that it should say saving ... instead, and when I hit save, it looks like we're in good shape. So we have all of our tests passing. Now that we've seen some basic examples working with React test utils, let's build the same test with Enzyme for comparison. We just saw a lot of boilerplate code that was required to write a few simple tests with React test utils. So in this lesson, let's use Enzyme to write the same exact test and see how much simpler it is. Now before I move on, let's rename our React test utils test so that it's clearly separate from the Enzyme test that we're about to create. And I'll just rename this, and I'll call this courseform.reacttestutils.test.js. Now let's create our Enzyme test file, and we'll call this courseform.enzyme.test.js. Now to get started, let's add in our imports. I'm importing Enzyme here, and as you can see, I'm using named imports for the mount and shallow functions that are part of Enzyme. For now, we're just going to use shallow, but this is Enzyme's wrapper for React test utils shallow render. Now for convenience, I'm still going to create a setup function here at the top, but this time, our setup is going to be far simpler. As you can see, we are still defining our props, and then we just call shallow and pass in the component that we'd like to render, which in this case, we're going to shallow render the course form with the props that we've defined up above. So it's nice and simple here. None of the other boilerplate setup that we did for our React test utils are necessary here. Now let's duplicate our first test, which remember, it simply checked for the existence of the expected form tag in h1. So I'll type this out and then I'll explain. I'm just getting the wrapper component back from our setup call and then using the find function to get the form. And then I can say .length, and that chains my calls together like I would in jQuery, and say I would expect the length to be 1. And I'm also saying that I expect it to find the form and only find one form. And then I can look for an h1 and get the text of that h1 and expect it to equal manage course. So this reads much more like English. Now let's add a test for the save button and see how they compare. Again, the first line is really just the same boilerplate as the first one, so we can get our reference to our wrapper. And then we start with our assertions on the second line. We find an input, we want to get the props of that input, and the props that we're looking for is value. So we're finding the input, looking at the props, getting the value, and then expecting it to be save. It should be saved because we're passing in false for saving. Now, when saving is false, we expect it to be save, and when saving is true, we expect it to be saving. So you might have noticed that our tests don't run just yet. The reason for this is that it doesn't run our watch because we have new files. So I'll actually have to hit Control C to get out of this and rerun the command so it picks up our new files that we just created. We'll have to remember to do this every time that we create new test files. So it looks like I have a typo somewhere. Okay, so I've misplaced one of my parentheses here. And now we can see that we have all 7 tests passing. And our tests are just sitting here at the root actually. So one other thing I actually forgot is to add a describe block. So let's add one here and let's do that now. Okay, there we go. And now in the console, you can see that it displays much more nicely. I clearly have 3 tests via Enzyme and 3 tests via React Test Utils. Now, let's look at them side by side for some comparison. To me, Enzyme is the clear winner. It requires much less code, and the code that's there is much more readable. It clearly conveys intent. It's also less fragile. Notice how I had to look for the 5th index in the array to get a reference for this save button when using React Test Utils. But with Enzyme, I was able just to use the find function to do the same thing. It's much less fragile. So with that said, let's wrap up this module with a quick summary. In this module, we reviewed a long list of testing frameworks to choose from, but ultimately used Mocha, Expect, React Test Utils, and Enzyme to test. We saw many potential approaches for testing React components, including in-browser via headless browser and in-memory. We ran in-memory tests using JSDOM's virtual DOM, and we ran them via Node. We also wrote tests for React presentational components, both with React Test Utils and Enzyme. We saw how Enzyme provides a superior API for interacting with the DOM, and now that we have seen how to test simple React presentational components, in the next module, we'll wrap up our testing coverage by exploring how to write unit and integration tests for Redux.